Hello, everyone. D. Alfred Ostrowski here. In this recording, I'm going to be giving an introductory tutorial to Golang HTTP-based microservices using Amazon EC2 resources. So we're going to start from square one, only assuming that you have an Amazon account and some familiarity with navigation of the Amazon resources. Here I have the EC2 home screen up, and I'm going to start with a fresh instance. So let's get started. So I'm going to do launch instances. And I'm going to use Ubuntu. I'm going to use low-end instance in this case. I don't need a lot of horsepower to perform this demo. So I'm going to click Ubuntu. It defaults to Ubuntu 2204. I'm going to keep the T2 micro free tier eligible. I'm going to assume that you already have a PPK key generated. I'm going to pick an existing key pair that I have existed. I'm going to launch instance. The only thing I need to do at the administrative level beyond this is to double check my security rules that I can have access to be able to run a client to my microservices as they're being run from the command line. So I'm going to click into instances, going to drill down to the instance that I just started. You see it's pending right here. I already have an IP address and so forth. I'm going to click into security and click into my security groups. Look at my inbound rules. So scroll down a little bit and do an edit inbound rules. On the right-hand side, you see SSH is my default. So I'm going to set that to all traffic. I can set just IP4. I'm going to set up another rule just to make sure I got all the bases covered, and do IP6 as well. Save my rules, and now I'm good to go. I'll be able to access it. Of course, the security is not going to be the same level, but we're just playing around doing some initial experiments here. So let me go back to details, and I'm going to take note of my IP4 address, and I'm going to start up two PuTTY clients, one to access my machine to run the server, and one to run the client to that machine. Pull my PPK key. I set 30-second on the connection, so it won't time out. And I'm going to bump up my font. You could use any client that you're comfortable with. PuTTY is the tried and true standard, and I'm into my instance here. I'm going to do it one more time. So I have a second client here. Bring in my host name. Select my PPK key. Set my connection and the font, and I'm good to go. The advantage of this, with any of the installs, which are nominal in this case, but as we scale up, you should be able to exactly duplicate my experience, because we're running on the same exact hardware and operating system configuration. First thing I'm going to be interested in is installing Golang. I'm going to need to do a sudo app update, and I'll put the commands that I'm running in an associated GitHub, so you don't have to worry about pulling them from this video. Here I'm installing Golang. I'm going to default to yes. I did a sudo app install Golang Go, and I just defaulted to yes. That's not going to take long. So I'm good to go with my first example. I'm going to install routing software for a slightly more advanced example, but let's just get into it right now. So this is just about finishing. Here, I'm going to start a basic Golang web server. I'm going to call it intro.go. I'm going to cut paste my code in here instead of copying it line for line. Your basic Golang web server. Here, I have import a package main. I'm going to bring in formatting and NetHTTP, the networking library. I'm going to serve a function. It's just simply going to print out my URL path. It's going to take as input the two HTTP objects for request and response writer. It's going to be served at the base root directory of the server, and I'm going to set up a listener, which, as all web servers do, serve that function at a port 8080 and just listen for requests. You might have seen very similar examples in a number of the videos. So now I'm ready to start up my web server. I can do a go run intro.go. Now I'm ready to do HTTP requests. To do that, I am going to want to grab the public DNS that has been associated with my newly created instance. So I have my server running in one client, and in the second client, I'm going to run a curl utility, and the curl is already provided with Ubuntu, so I don't have to install anything special to run that. Do a curl-x, do a get command emulating what we experience with any web browser, those basic REST style commands. I'm taking that DNS, make sure I set up my port appropriately. And there I have my output from my web server running appropriately, generating the path and the message Ubuntu. I can even extend that and extend that URL, and you can see that show up here in my path. So this is about the most basic web service, but you can appreciate even from these simple examples how you can leverage this as a building block and view it now, not just as a web server, but a microservice that can be accessed through the curl utility using your basic REST style commands. And in that function being served, I could put it in a backend database or call any type of custom software that I might be available. Let's try a more sophisticated example using more advanced routing and parsing the routing parameters. For that, I'm going to use a library, gorrilla to do that, which is very popular for this type of application. To accomplish that, I'm going to have to do the install, and I'm going to do a sudo apt install Golang GitHub gorrilla dev. And here I just dropped out of my browser, and in my initial terminal, I ran sudo apt install Golang GitHub. I may have done that pretty fast, but you can see the command here. And again, I will maintain all the commands on the GitHub, and I'll make it associated with this video. I'm also going to need a definition file go.mod. So I'm going to do an init command to generate that and a second command to configure it. The first command is go mod init gorrilla-mux. So I created a new Go mod file, and I can cat that at this point. As gorrilla-mux Go 1.18. As prompted, I am going to install Go mod tidy, which will make sure that my source code, the Go mod, matches the source code in the module. Also going to do a go get command and download the appropriate software to support that functionality. Now I'm going to load in a new server. Just call it intro2. Let's call it intro2.go. Cut paste the code in here, a little more extensive version. This is going to support more advanced routing and, most importantly, leveraging the gorrilla software to support more advanced parsing of those routing commands. Essentially, I'm building extensive function calls using our REST-based capability. And by using this routing software, being able to parse out that information, that you can start to envision how I can send these commands through the REST commands, calling served functions, if you will, supporting a true microservices-based architecture, where I send information from my client to the backend code and be able to run that. Let's run through that code real quick, and then we're going to do a quick demonstration of that. Import the main. I got a couple extra libraries here. One for logging. I have my tried and true HTTP library, time function, and the gorrilla library to support the routing. Here I have extra functions where I'm going to parse out data. You see I have many regular expressions here, parse out numerics, and print that to the screen using the formatting command on the next line, as well as values associated with an extended invocation. And here I have a server. I have some extra commands here. When you're serving this, it's not necessary at this point, but if you serve it as a deployed facility, which is again going to be a part of completely setting up a deployed microservices architecture, I'm going to be concerned about setting the appropriate timeouts, which are not supported by the default library. So I have to write in the timeouts as indicated here, and I log the appropriate errors. So let's start that up and see how it runs. Do go run intro to .go, and I'm going to run it in the same fashion. I'm going to grab my DNS that I had before, public DNS, and I have my server in the upper left, and I'm going to run my curl client using representative state transfer or REST style commands. I'm going to stage my command with an updated DNS off screen, and I'm going to pull it in so you can see it and observe the response. So I got two basic commands. Again, I'm going to use curl to run these commands. Curl HTTP with my domain, but in this case, I've extended the path to resources with the numeric 123. You see 123 is being parsed per the served code. And I'm going to call it again, extending it again to invoke that second function to pull the values path here. And you can see that the values and 456 is being parsed out of that extended procedure call. So again, at a very simplified level, we can view microservices as served functions. And that's what the REST style of programming allows us, using your basic HTTP commands capabilities to be able to support these operations, primarily using the get and post commands. And this is a good starting point to have an appreciation of the construction of your microservices-based architecture, in this case, using the Golang and associated libraries. So I hope this helps. I've tried to generate more content where I have more extensive examples building on these general concepts. Thanks for listening. Take care. Talk to you soon. Bye now.